The second problem on this fourth formative assessment for the term is about graphing rational functions. It just says, sketch the graph of this rational function right here, this one. And it tells us all the things that we should include in our sketch. Asymptotes labeled with their equations. Okay, I want to make sure the graph is positioned on the correct sides of all the asymptotes. And I want to make sure that the graph actually approaches the asymptotes where it should. And then I'm going to make a note about the end behavior, and I'm going to use the appropriate notation to do that. So let's take a quick look at this function. First of all, let's think about the vertical asymptotes. What causes vertical asymptotes in rational functions like this is when the function is undefined. And you can see that if x is equal to -2, then my denominator is equal to 0. And then I'm trying to divide by 0, which is undefined. So the value of x equal to -2 causes this function to be undefined. So there's going to be a vertical asymptote on this side right when x is equal to -2. So I'm going to draw that in. Here's how we draw a vertical asymptote. It's a dotted line. Put arrows on the end to show that it goes on forever and ever. And we were told to label the equation, so I'll just put x equals -2 right here. Now, that's one of our two asymptotes. The other asymptote that I need to think about is the horizontal asymptote. And for this, I'm going to think about what happens when x gets really, 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 really big, or really, 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 really small, or like a big negative number. And I can do that by taking a look at my equation and noticing that when x is really big, this 3 becomes insignificant on the top. And when x is really big, this +2 doesn't matter. I mean, 1,000,000 plus 2 is still pretty much 1,000,000. So the way I describe this, I might just do it over here. For large x, g of x is approximately equal to -2x divided by x. And that equals -2. So my function g of x has a value of -2 when x is really large. And that comes from really just eliminating that +2 on the bottom, and because it doesn't matter when x is really large, and eliminating this 3 on the top, and because it doesn't matter when x is really, really large. So I got a horizontal asymptote at y equals -2. So I draw a horizontal line, dotted line, and I was told to label it with the equation. There it is, y equals -2. All right, so there are my asymptotes, and that's really the first step. All asymptotes labeled with their equations, done. You might take a moment just to confirm that you like those values for your vertical asymptote and your horizontal asymptote. The second part, or the second bullet here, is really about positioning the parts of this graph on the appropriate side. And to do this, I'm just going to plug in some numbers and for x and see what comes out. I like 0 because it's a really easy number to plug in. And notice that x equal to 0 is on this half of the graph. So I'm basically going to figure out right now whether my curve is going to be up in this quadrant or whether it's going to be down here. So imagine putting 0 in right here for x. I get 3 divided by 2, that's 1.5. So when x is 0, y is 1.5. It's like somewhere about right there. So I have enough information to draw the first half of this curve. When I draw it, I want to make sure that I'm approaching the asymptotes. Okay, so that it's going to be in this quadrant right here. So I'm just going to draw my curve like this. Now, to figure out what happens on the other half of the graph, let me just pick a number on this half, like -3. Okay, and if I put -3 in for this x, I get -6. 3 minus a negative 6, that gives me 9. And then if I put negative 3 here, I get negative 3 plus 2. That gives me a negative 1. So when x is equal to negative 4, when x is equal to negative 3, my function has a value of negative 9. Negative 3, negative 9, somewhere down here. So I know that my curve is going to be on this side, and it's bounded by these asymptotes. You can't cross the asymptotes. You have to approach them, which I do here. And there's my graph. I have the asymptotes labeled with their equations. I have all parts of the graph positioned on the correct side of the asymptotes. I didn't draw them here or anywhere else. I put them in the appropriate side, and I figured out where to do that by just substituting some values in for x and plotting a couple of points. Now finally, a note describing the end behavior using the appropriate notation. End behavior happens when x gets really, really big in the positive direction or really, really small down here in the negative direction. So as x goes to infinity, my graph is getting closer and closer to negative 2. So this function, g of x, approaches negative 2 when x goes to infinity. And when x goes to negative infinity, my graph is approaching negative 2 also. So I'll use the notation to represent that. As x approaches negative infinity, g of x goes to negative 2. And that's the end behavior of this graph. And there's my graph with a note about end behavior.